Based on the text, Huang, Shiger, and colleagues would most likely agree with which statement about atmospheric NH3. Some astronomers searching for extraterrestrial life have proposed that atmospheric NH3, ammonia, can serve as a biosignature gas, an indication that a planet harbors life. Jingqing Huang, Sarah Seeger, and colleagues evaluated this possibility, finding that on rocky planets, atmospheric NH3 likely couldn't reach detectably high levels in the absence of biological activity. But the team also found that on so-called mini-Neptunes, gas planets smaller than Neptune but with atmospheres similar to Neptune's, atmospheric pressure and temperature can be high enough to produce atmospheric NH3. So option choice A says its presence is more likely to indicate that a planet is a mini-Neptune than that the planet is a rocky planet that could support life. This is incorrect because the text highlights that both a mini-Neptune and a rocky planet could have atmospheric NH3 to a certain level. And it doesn't highlight whether it's more likely for it to indicate that it's a mini-Neptune or to indicate that it's a rocky planet that could support life. It highlights that both are possible. Therefore, A is incorrect. B. Its absence from a planet that's not a mini-Neptune indicates that the planet probably doesn't have a life. Therefore, this is incorrect because this is saying that its absence from a rocky planet indicates that the planet probably doesn't have life. This is incorrect because the text clearly says that NH3 is a biosignature gas, which is an indication that a planet harbors life, meaning that usually means that if a rocky planet, has this level of NH3, then it has a certain amount of biological activity. But this doesn't mean that it's a guarantee that it doesn't have life or has life. Therefore, this option choice B, which says that its absence from a planet that's not a mini-Neptune indicates that the planet probably doesn't have life, is incorrect. C. It should be treated as a biosignature gas if detected in the atmosphere of a rocky planet, but not if detected in the atmosphere of a mini-Neptune. This seems to be the correct answer because the text clearly aligns with this, where it highlights how atmospheric NH3 is a biosignature gas, and that if it's detected on a rocky planet, that means that there's a certain level of biological activity that produces this level of NH3. But it's also possible that mini-Neptunes, which are gas planets which cannot support life, have the capability to produce this level of atmospheric NH3. And therefore, this NH3 should be treated as a biosignature gas if detected on a rocky planet, but not in the atmosphere of a mini-Neptune. Therefore, C seems to be the correct answer. D. It doesn't reliably reach high enough concentrations in the atmospheres of rocky planets or mini-Neptunes to be treated as a biosignature gas. This is incorrect because nothing in the text suggests this, where it highlights, on the contrary, that mini-Neptunes can have a high enough concentration of this atmospheric NH3, and therefore D is incorrect. And the correct answer is C.